The evolution of digital research in Canada has reached a point where data management is a foundational requirement for scientific integrity. Under the Tri-Agency Research Data Management Policy, institutional strategies and data management plans are now essential prerequisites for funding. The primary bottleneck in this landscape is the disorganized state of active working directories. This mess on the hard drive represents the single greatest barrier to data preservation and reuse. When directories lack structure, researchers face higher risks of data loss and personnel turnover. Disorganized files prevent seamless collaboration and block the effective deposition of data into national infrastructure. Achieving the FAIR principles, ensuring data is findable, accessible, interoperable, and reusable, requires building a digital architecture from the ground up, starting at the individual file level. Engineering file names for machine readability and structuring folders into processing pipelines prepares datasets for high-speed transfer into national repositories. Implementing these standardized practices reduces the cognitive load of a project and creates the technical framework necessary for modern scientific discovery. A file name functions as the most granular unit of metadata. It provides a layer of context that must be interpretable by both humans and machines, without the need to open the file. Machine readability begins by eliminating spaces, which act as delimiters and break file paths. Using snake_case maintains string continuity. We also remove non-ASCII symbols like ampersands, which prevent automated processing. Standardizing alphanumeric syntax prevents record collisions, ensuring scripts iterate without interruption. Adherence to these naming conventions acts as a technical safeguard, ensuring that data remains accessible and processable across different computing environments. Traditional date formats are inherently ambiguous. A string like 01-02-03 can be interpreted as 3 different dates, creating errors in longitudinal studies. The ISO 8601 standard resolves this through an internationally recognized numerical notation, a descending order of year, month, and day. Computers organize strings using lexicographical sorting. This alphabetical method determines how files appear in a directory. Because ISO 8601 orders units from largest to smallest, the computer's default sort matches chronological time, creating an immediate logical timeline of the project's progression. Utilizing ISO dates ensures that a dataset remains organized by time regardless of the operating system or file explorer used to view it. Using ad hoc suffixes like final or V2 obscures the true status of research. These vague labels increase the risk of collaborators performing analysis on outdated or incorrect data. Semantic versioning provides a framework to encode the nature of a dataset change directly into the version number, using a 3-part structure. A major version increment signals incompatible changes, like transforming the dataset structure. A minor version indicates backward compatible additions, such as adding a new year of survey responses. A patch version is reserved for bug fixes, like correcting a single typographical error. To maintain scientific verification, datasets must be immutable. Once a versioned package is shared or cited, its contents must not be modified. Any further changes require a new version number. Applying these rules ensures that every researcher citing a dataset is referencing the exact same state of the data, eliminating versioning errors. Deeply nested folder hierarchies can exceed the operating system's path length limit, making it impossible to move files. The conveyor belt model avoids this by using a shallow hierarchy, dividing folders by activity into raw data, analysis scripts, and outputs. Raw data is never modified. It moves through checkpoints where scripts clean and analyze the information, ensuring the original instrument output remains pristine. This approach relies on relative file paths. While absolute paths fail when a project is moved to a different machine, relative paths refer to the location of files within the project folder itself. Relative paths allow the entire directory to be shared or uploaded to a repository without breaking the analysis pipeline or requiring manual adjustments. Combining shallow hierarchies with relative paths transforms a research directory into a portable and reproducible execution environment. Even a perfectly structured directory is unusable to the scientific community if it lacks documentation explaining how the data was collected and interpreted. Every dataset requires a README file that details data collection methodologies, software dependencies, and licensing information like CC BY 4.0. For tabular data, this is supplemented by a data dictionary. This document defines every variable, its units of measure, and the numerical codes used for missing values. Storing data in proprietary formats introduces the risk of software rot. If the original software becomes obsolete or the manufacturer changes the standard, the files may become unreadable. To ensure long-term accessibility, files should be converted into sustainable, open, and lossless formats, such as CSV for tables or PDF-A for documents. These documentation and formatting steps ensure that research data remains interpretable by the global scientific community long after the original software is gone. Organized data can be deposited into national platforms like Borealis or the Federated Research Data Repository. Borealis is designed for granular file sharing, automatically extracting variable-level metadata from tabular formats. FRDR handles terabyte-range datasets using Globus Connect for high-speed transfer. Your local organizational choices dictate the public architecture. FRDR preserves your exact folder hierarchy as the permanent interface for future users. Pre-deposit organization ensures that the repository record is clear and functional, rather than preserving a disorganized working environment. Evidence shows that articles providing access to organized raw data receive significantly more citations. In some fields, this citation advantage is as high as 69%. Datasets are increasingly recognized as primary scholarly outputs. They receive unique DOIs and are tracked by metrics like the S-index, which ranks researchers by the citation frequency of their shared data. Mastering the research directory ensures that data remains reproducible and accessible, allowing today's discoveries to serve as the building blocks for future scientific analysis.